This conference will now be recorded.
And link to access your topic. So click on create subscription.
Hello?
Yeah, tell me.
Your voice is not audible, sir.
Just now it is audible now.
Yes, sir. Now it's audible, sir.
Yeah. So after creating the topic, so here you can have a create subscription. Click on create subscription. This is the topic ARN. ARN means Amazon resource name. Here endpoint. Select a protocol. So how do you get the message by using email or Amazon SQL service, Amazon AWS Lambda service, or simple mail service, simple message service? So I am selecting email service. Select email. Write down your email ID. For example, I am writing My mail ID is 3for1@gmail.com. So like you have to write your mail ID. How do you get the notification? So click on create subscription. So here what it's showing, already a valid mail address 3for1@gmail.com. Give the .com, create subscription. So it is subscribed. Now how do you check whether it is working or not? Go to your mail ID which you given, log into that mail ID. So I given this one, sign in. Give the password. So now see ELB, Elastic Load Balancer. I given some name, notification name. So this is the topic I given, AWS notification subscription confirmation. Click on this one. So you have chosen to subscribe the topic. This is the ARN ELB topic. Click on confirm subscription. So subscription confirmed. You have confirmed subscribed srifor1@gmail.com for that topic, Elastic Load Balancer topic, your subscription ID. So everything you can get the mail IDs. So like this, whatever we are going to do the cloud watching services, so automatically Elastic Load Balancer or EC2 CPU utilization, whatever it may be, it will send the mail to our mail ID. This is called simple notification service. We have to register, automatically it will send. Now we are going to discuss of Elastic Load Balancer. So this is load balancer. Load balancer, you have to know whenever there is a high load on one application server, the load will take by another application server. This is nothing but a load balancer. For example, so every Wednesday there is a options, there is a discounts on Flipkart server. So many users they can log into, they can hit on the Flipkart server. They have to buy the gadgets. So whenever there is a high load on that application, the server may be shut down. That is the reason they are going to manage the load balancer. When is there is a high load on one server, automatically it will redirect the load to another server. So thousands of hits will come, lakhs of hits will come. So when the high load on the server, maybe the server going to be shut down, maybe the server going to be crash. That is the reason we are going to configure the load balancer. So without load balancer, see, every user directly whatever the application running on the instance, they are going to access. When there is a heavy load on this instance which is running on your application, automatically it will struck or it will down. That is the reason we are going to configure the load balancer. So with load balancer, now see, now I configured Elastic Load Balancer here. So automatically when there is a high load on this particular EC2 instance, automatically it will redirect the load to multiple instances. So load balancer used to route incoming requests to multiple EC2 instances. When there is a high load coming onto one instance, it will redirect the incoming request to other instances. This is the use of load balancer. So without a load balancer, if you're running on application, if there is a heavy load, automatically the application is going to be down. The server going to be maybe shut down. That is the reason we are going to configure the load balancer. With load balancer, whatever the heavy load is coming on one instance, automatically it redirects the load to other instances. So load balancer used to route incoming request to multiple instances. Simply we can explain. So elastic load balancing automatically distributes incoming application traffic across multiple applications and microservices and containers hosted on Amazon EC2 instances. So elastic load balancing automatically distributes. So we are not going to just if you configure load balancer, depending upon the requirement, automatically it will distribute the load to your incoming applications load to other multiple applications, and microservices means which are uh, in developing stage. Whatever the applications, whatever the programming you are developing, those are called microservices. And containers are nothing but a collection of uh, instances and applications hosted on Amazon EC2 instances. So here elastic is expanding means sharing the resources, sharing the incoming packets to other instances. It is secured. Integrated means integrated with multiple services and cost effective. So depending upon the requirement, so how you are going to use, they will charge the instances. So ELB features are load balance over EC2 instances within a VPC. So VPC, virtual private cloud, already we seen on our classes. We configured virtual private clouds. So you can also configure load balance over EC2 instances within a VPC. Also, you can configure support for both public and private IP addresses. So we seen in VPC, we configured one private subnet, we configured one public subnet. So you can also configure the load balancer between public and private IP addresses. Full control over the load balancer security group. So you can create a separate security groups on the load balancers, tightly integrated into the associated VPC subnets. So integrating means we are connecting different resources into one place. So tightly integrated into the associated VPC and subnets. So we are going to configure different Hyderabad VPC or Chennai VPC, like different VPCs we can connect, and within the VPCs we have different subnets. So it will integrate with the associated VPC and subnets. Health checks. So when you configured elastic load balancer, each and every time it will go and check the instance health status, whether it is properly receiving the incoming requests or not. Is there any problems? If it is failed, what we have to do? Everything it will check. So health checks ensure that request traffic is shifted away from a failed instance. For example, one instance is failed. Automatically, whatever the traffic is coming onto the particular which is the failed instance, so it is shifted to other instances. So that is the reason every time in elastic load balancer, each and every instance health checks is going on. Whenever any one instance health check is not properly is there, it will automatically shifted the request to other instances. Idle timeouts. So idle timeouts allow for connection to be closed by the load balancer when no longer in use. So length of time that can idle connection should be kept open. For example, I given, so the idle timeout is 5 minutes. 5 minutes means 300 seconds. So whenever there is no request will come on 300 seconds, what we have to do, we can configure. So idle timeouts allow for connections to be closed by the load balancer when no longer in use. So it is not using by last 5 minutes or 10 minutes. It is not using it is not getting any request. So it will shut down the system. It will stop the instance. Maybe it will terminate the instance. Depending upon the requirement, how we are going to configure, it will do. Length of time that can idle connection should be kept open. So we have to keep it open. This is the length of time. If any instance is not getting any request from last 5 minutes or 10 minutes, whatever it may be, whatever you set the timeout time, so automatically it will stop the instance for both client and backend connections. So it will apply for both client side and backend connections. Defaults to 60 seconds. So default timed out time is 60 seconds means 1 minute, but can be set between 1 and 3600 seconds. So depending upon our requirement, you can set the timed out from 1 to 300 seconds. Whatever by default is 660 seconds, 1 minute. So you can set the time between 1 and 3600 seconds. Timeout should be decreased as you go to the stack. So depending upon when you create a elastic load balancer, so depending upon your requirements, you can decrease the timed out time. High availability using multiple availability zones. So for example, I configured load balancer in same availability zone. For example, availability zone is nothing but a data center. Already we discussed. So we have three availability zones in Mumbai, means three data centers are in Mumbai. So South 1A, South 1B, South 1C. So if I configured elastic load balancer on one server, maybe the entire data center is down. So there is no use of load balancer. So both the instances which are connecting in the elastic load balancer, all are down. That is the reason when we are going to configure the load balancer, you have to choose multiple availability zones. Then if one data center is down also, you can get the information from other data center. Here simply I am telling you data center is nothing but a availability zone. So when you are going to configure ELB, so you have to use multiple availability zones. Otherwise, there is no use of ELB. There is a use if data center is down. So your total EC2 instances which are running on ELB all are down. That is the reason one EC2 instance in one availability zone, another instance is another availability zone, another instance is another availability zone. So if it is one down, two can work. If two down, one can work. So that is the reason use multiple availability zones. So this is elastic load balancer. Then auto scaling I will discuss tomorrow. Both we are going to see practical. These are two interconnect. Auto scaling. So ECT auto scaling. So types of scaling: vertical scaling, horizontal scaling. So vertical scaling means you have a, for example, you have a instance. So you need more memory or you need more storage, then within the same instance only, it will increase your instance size, it will increase your elastic block storage capacity. That is within the same instance only. Depend, for example, I have a laptop, I have a 2 GB RAM. So I want to increase. So I can put another 2 GB RAM. Again, I want to increase the RAM because I have some more database is running. So my laptop capacity is more maximum 8 GB RAM. So I cannot increase. Like that, my laptop also supports only 2 terabyte of the hard disk. So I cannot go beyond that capacity. That is the reason in vertical scaling. So it will change the instance size and it will increase your block storage capacity. Block storage is nothing but your data capacity. But horizontal scaling, it will add and remove instances. For example, there is a one server is going on in my cloud environment. That is nothing but server is nothing but EC2 instance. So when it is required more incoming requests, automatically it will create another instance. So if it is not required, automatically it will remove another instance. For example, my laptop is not enough to manage the particular databases. So I have to buy another laptop in general scenarios, physical environment. But in cloud environment, if one EC2 instance is not capable to manage that bunch of database or whatever the storage, automatically it will create another instance. When the requirement is not there, it will remove the instance. So depending upon your requirement, automatically it will add, automatically it will remove. For example, you can take Flipkart only. So we started one business. So every Wednesday, I required 3 servers every Wednesday because every Wednesday I received so many requests from the customers. So one server is cannot able to provide the resources to customers. That is the reason I have to buy another 2 servers. I have to keep. So only Wednesday only that 3 servers will work. So another days they are going to be idle, but we have to invest them. So the waste of the money for one day purpose. So lifelong we are going to manage the servers. So, but in cloud computing, so auto scaling is a concept is called. Depending upon the requirement, it adds the instances, and depending upon the not requirement, it will remove the instances automatically. So here, elastic load balancer just now we discussed, it will including in auto scaling. So adding and removing instances and automatically provide the load balancing between the instances and auto scaling. Auto scaling means automatically it will, depending upon requirement, it will add the resources. So if it is not required, it remove the resources, adding and decreasing the resources. So for example, this is workload monthly. So from first day onwards, every day up to 25th day. So my server is going on smoothly. One server is enough. But to peak processing days are there. For example, we have a Dasra, Diwali vacation occasions came. So in that days, so many companies, Big C or something, they will provide so many offers. So in that particular days only, they have a good business. So they have heavy requirement is necessary. So so every month, first day to 25th day, my business is going smoothly. I need only one instance is required. But these 4 days, I given some offers. I need some other resources, other instances. Automatically, it will go to your workload. How much you required? Automatically, it will add. Whenever your offers is completed, automatically it will down. Again, your work is going to be normally. See, monthly predictable peak processing, only 3 or 4 days our business is going to be do because we are going to give some offers. That 3 days or 4 days, heavy business is going to be in our company or whatever the shops are there. So, depending upon the requirement, it will add. Whenever your work is completed, again, if you come into the normal stage, it will remove automatically. Now, next. See how much you saving here, 75% you saved, because only whatever these 3 days, 4 days, the instances which used, the resources which used, the 3 days, 4 days money you have to pay. So no need to pay every day for using these resources. Depending upon the capacity of resources which you used, that much only you have to pay. In real time environments, means physical environment, so we have to pay the money, we have to buy the servers, but here no need to require. So up to 24 days you can use your own instance. So after that, whenever the peak hours are there, peak days are there, automatically it will add the instances. Whenever the peak days completed, automatically it will remove the instances. You can save your money. So when do you need auto scaling? I have got instances serving a business impacting application. So whenever there is application which is impacts my business, I can go for auto scaling. So if my instances become unhealthy, I had like them replaced automatically. Maybe your instances may be unhealthy, maybe some problems will come. Depending upon that situation, you can select the auto scaling. Whenever your instance is unhealthy, automatically it will replace with another instances with same configuration. So I would like my instances distributed to maximum resilience. So the depending upon the customer requirements, I can expand the resources to all users. So I would like to my instances distributed to maximize. So maximize how much they can utilize, that much I can utilize. That is the reason I can go for the auto scaling. So auto scaling concepts, the configuration part, auto scaling groups we have to create. EC2 instances are managed by auto scaling groups. So you have to create a group first. Create auto scaling groups by defining the minimum, maximum, and optionally the desired number of instances. So in while creating auto scaling groups, you can select minimum instances, maximum instances, minimum 2, maximum 4. So it will uh, constantly run the 2 instances. When it is required, how much maximum instances you prefer there, it will go to up to there. That is depending upon your configuration only. Next, launch configuration. So launch configuration, you have to provide the information of your Amazon machine image and EC2 instance type size, because same configurations we required. So T2.micro or C4.large, X large, there is a configuration we are going to select. So same type configuration machines only we are going to select. That is, we are going to select in the launch configuration. And scaling plan. So a scaling plan tells auto scaling when and how to scale. So when you require auto scaling, we have to tell. So create a scaling plan based on the occurrence of specified conditions. Dynamic scaling or a create plan based on the specific schedule. So you have to select as a dynamic scaling. So if the instance is more than CPU utilization 60%, create automatically another instance. Like that you have to write. So create a plan based on specific schedule means you have to give the schedule in this particular date to this date. You have to add the 2 instances or 3 instances. Those we are going to see while configuration. So auto scaling groups always keep minimum number of instances running. Already we discussed. So minimum instances we have to select while configuring auto scaling, minimum 2. So it will keep minimum 2 instances in auto scaling. Launch or terminate instances to meet desired capacity. So when the CPU utilization is more than 70%, launch another instance. When the CPU utilization less than 60%, terminate the instances. So we have to write that one. Never start more than maximum number instances. So maximum instances, for example, 2, 4. So never start more than maximum. So I given 4 are the maximum. So if capacity is not desired also, it will not start any other instance. That is also you have to tell. More than maximum. Keep capacity balanced across availability zones. So capacity balanced means already we discussed same capacity of the servers we have to keep across the availability zones. So availability zones already we discussed like a different data centers. Same capacity balanced servers we have to pick. Here also Oracle database, same also Oracle, here also 4 GB, there also 4 GB RAM, same capacity. Here T2 micro, there T2 dot micro, same capacity. Replace unhealthy instances. If there is a unhealthy instance, if there is a problem with the instance, automatically it will replace. So here they given minimum 2, maximum 2, desired number of instances 2. So launch configuration already we discussed. In this launch configuration, we have to select the type of instance, size of instance, 8 GB, 30 GB, whatever it may be, which machine image you are taking. So Amazon machine image or Red Hat, Windows Server, whatever it may be. Security groups which are configured on the first instance, same security groups and same SSH keys, IAM, identity access management, whatever the configurations we done, same it will maintain. User data and bootstrap while booting the system, we can write some programs that is also same exactly like we can call as a clone. So whatever the first instance I selected, same capacity, same configuration you have to maintain while launching the new instance. So auto scaling plans determine when the auto scaling groups will scale in or out. Desired capacity greater than current capacity last instance. So current capacity is there 2, desired capacity is 2. If it is greater than that one desired capacity, it will launch the new instance. Desired capacity and current capacity is less than, terminate instances. That is our configuration purpose. We can select desired capacity 2, current capacity 2. If it is going to be greater than desired capacity, create a new instance. So desired capacity 2, current capacity is 2. So if it is less than the desired capacity, it will terminate the instance. Next, these are default, manually, scheduling, dynamic scaling. While we are going to configure, we are going to select current capacity of the health instances, modify desired capacity, scale in or based on time events. That is, we are going to configure. While we are configuring, it will ask these questions. Dynamic scaling, scale based on CloudWatch metrics. Already last class we seen the CloudWatch. So more than CPU utilization 20% or 30% or 40%, automatically create the new instance. Less than 30%, terminate the instance. So health checks performed periodically. Instances marked as unhealthy when checks fails. Unhealthy instances are terminated and replaced. If there is unhealthy instance is there, automatically terminate. With the same capacity, it will replace that instance. Termination policies longest running. So it is running from the old instance, it will terminate first. Oldest launch configuration. So I did the launch configuration 1 year back. So when I configure launch configuration, that type of instances, it will terminate. Closest to full billing hour. So which instances is going to be get the full billing. So it will terminate. So rebalancing of capacity across availability zones takes precedence. Already we discussed. So same capacity of the servers, we have to make it on different availability zones. So this is the life cycle, scale out event, instance launch pending. So in service working fine, health check is failed, it is terminated. So instance launching pending, in service, scale in event, if it is running, it will open the instance. When the health check is failed, it will terminate. When the health check is good, it will not terminate. This is the way it will work. So auto scaling, this is demo purpose. Auto scaling minimum requirements, minimum 1 instance is required. Here they given maximum 3, cooldown 300 seconds. Scaling policies, CPU utilization greater than 30% for one time for 60%, add another instance. Then wait 60 seconds before next operation. So this is already we configured in CloudWatch. Scaling down, CPU utilization less than 10% for two consecutive periods of 60 seconds. So one time it will check 1 minute, wait. Second time also it will check. Even if it is less than CPU utilization 10%, remove one instance. Then wait 60 seconds before next operation. This is the way we can configure the auto scaling. Okay, tomorrow we are going to see the configuration of elastic load balancer and auto scaling. Okay.
Okay, sir.
Okay.
Sir?
Tomorrow
Hello?
practical we can see. Tell me, Kapil.
Yeah, yeah. Sir, please send sir RHEL 7 videos. Sir, 7, 8.